Thanks, Rick. Hello, everyone. Well, they say you play World IA Day twice in your career, once on the way up and once on the way down. It's good to be back. And kind of fitting, actually, because the last time I was here was in 2016, when the closing talk of the night was by Mr. Paul Risson, who's in the audience tonight, when he talked about story webs, which is something that we're going to be looking at tonight. Even then, he was drawing on ideas that go even further back, which we'll also touch on. But tonight, this is all about how we're going to bring some of those old ideas back to life with the power of AI and IA. So back in the mid-2000s, domain modeling was the thing at the BBC. It was quite the vogue in IA, and it seems to be still tonight. All about slicing content into semantic chunks, connecting it by meaning, not just by container. So we wanted to reveal the connections and create new user journeys, truly a creative act of information architecture. It was about structural creativity and designing revelation, if you will. The BBC Mythology Engine prototype took this further in 2010. Applying domain modeling to drama. So we wanted to model out, or the team wanted to model out, not just facts, but stories themselves. Things like Doctor Who, but also EastEnders and the Archers. Could their narrative architecture be mapped? Could characters and events and the relationships between them be properly modeled and represented online? So Tristan Fern and team built a prototype website to explore this, aiming to unlock deeper ways to navigate and understand these rich fictional worlds. And my old buddy Theo Jones remember that bit. Beautiful design work by Theo there as well. You get the idea what the Mythology Engine was there to do. Hello, I'm Mike, and I've been working with managed content for about 30 years. You may remember me from the book I wrote in 2017 with Carrie Hain. You probably don't remember me from Newsbang, the AI-generated podcast I ran for 366 consecutive days last year. Truly AI comedy's finest hour, spread over about 150 hours of content. Last 20 episodes, pretty good. So I've been diving into Gen AI as truly a creative medium. Like Paul, I also see sort of IA as a creative medium, and it's one thing to kind of deal with, you know, enterprise knowledge graphs and what have you, but I think we can still apply a lot of those that thinking to more fun, more creative, more fictional things. So let's do that. And quickly, let's just hear from Paul back in 2016. What did he say? He said that this video does not automatically play when we click it, and also we can't move the mouse over to the other side of the screen. You got it, Rick's got it. Oh, there he is. Right on. Shut up. Right. Crucial point, isn't it? In stories, the events and character actions are independent, really, of the on-screen chronology. If you think about EastEnders or any soap, really, so much of it happens concurrently, not linearly. So that points us towards a kind of graph structure rather than a linear one. This isn't just about websites, it's about the kind of fundamental architecture of narrative itself. Brings us on to this guy, Russian folklorist. I wish I had that job title. Vladimir Prop talked about the difference between fabula, which was the order that things happen in a story, and shuzhe, which is the way that we experience it as a reader, as a viewer, whatever. If you think about things like Memento or Back to the Future, or many of the other examples that we'll look at tonight, you can see that things happen in strange orders, and what's happening to the characters is perhaps different to what we see as viewers. So it suggests this kind of graph, non-linear structure, sort of early attempts at the BBC Mythology Engine. Really the engine behind the website was this kind of stuff, visualized as here, very kind of RDF Tripoli-like complex graph. But the problem was that that was all very well for a demo, for a production prototype, but creating these story graphs is really hard. It was, you're having to sort of get into this sort of post hoc, semi-bespoke modeling of each individual story, and that's very time consuming. The content's in the wrong shape. You heard Theo talk about the fact that they had to hire a freelance writer and get all that data generated. The data model itself, because it's such a big effort, becomes kind of a big bet, because you really want to get it right before you're going to go and do all that work. So a lot of big design upfront, if you like. Great in theory, but incredibly hard and expensive to scale up or even trial. Because the benefits, as we all know when we deal with sort of knowledge graph type stuff, you really only start to see the benefits when you do it at scale. So then came AI. For my money, LLM is the best thing to happen to content management and information architecture in years. Product managers might sell them as knowledge bases or sort of oracles of reliable information, but they're not, are they? What they are is brilliant token transformers. They're very amazing transformers. They take input, they do reasoning on it, and they turn it into output. So suddenly we've got a cheap and powerful way to extract and even sort of fill in the blanks in content, which is a big market. As Sally and Rich touched on earlier, synthetic data is big business, 3.7 billion by 2030, not just about organizing existing data, but creating entirely new data sets, which can be, if you've got use cases like anonymization, permissible test data, even sort of copyright-free data sets. You're creating net new data from the reasoning on existing sources. So for this World IA Day, I revisited the Mythology Engine concept inspired by Paul's story webs. And I want to show you something called Fabula, which is a tool to explore this idea of stories as networks. Now, it's Python-based, a bit of code, not pretty, but it uses AI to analyze screenplays or TV transcripts and extract the dramatic elements that we need. And then it aims to represent a story as a connected web of moments from every character's perspective. Let's see how it works. The approach is fairly straightforward. First, we split an episode into scenes, and then we pass each scene through an LLM pipeline for reasoned data extraction. And by reasoned, I mean it can look at the data that's there, and it can also sort of reason about data, which is implicit, but not literally that. So we resolve then all the entities across scenes to ensure consistency, and then finally we output everything as structured JSON. We'll look at that more in a second. Our core tech stack is Python. We're using OpenAI models and a library called BAML, which has been an absolute lifesaver in getting structured output properly out of LLMs. Let's talk schema design. So our principles. Universal, one ontology to fit them all. Many people have tried that crazy idea, never works, but it might work for us. It needs to support continuing stories. So not just sort of looking at a story after the fact and deciding who was the hero and who was the villain, but actually letting the story unfold in real time, as it might with a soap opera. And people are just people who do the things, and then we decide laterally about whether we think they're goodies or baddies. It needs to enrich metadata with reason analysis, and not just sort of raw data in, raw data out. And crucially, it has to support that kind of narrative reconstruction and that fabulous sujet divergence where things can happen in a different order than we see them. And support additional ontologies, because again, we don't want to make the data model a big bet. We want to be able to extract different kinds of things from the same information. So for inspiration, I looked around at some existing drama ontologies. This is a snippet of Ontomedia from the University of Southampton. It's actually what the Mythology Engine was kind of based around back in the day. It's got lots of kind of objects for the things that you'd expect in stories, characters, items, and it's also got these events, and through events, characters can experience gain and loss. There's also this model, Drama, which is an Italian model, actually goes much more internal facing. It's much more about emotions and characters' sort of beliefs and values and goals at that, at any given moment, using what's called a belief, desire, intention model. So the ideal was some sort of best of both worlds hybrid, and this is what I've gone for. We have episodes and scenes, and then each scene is sort of a bucket of events. We have agents, which is a name for characters, people who have agency in the story, not necessarily secret agents, so sometimes they are. And organizations that they're associated with, locations that scenes take place in, objects that have some sort of significant value. And then we have these sorts of intermediate nodes, crucially, whereby to start with an event, and to connect it to an agent, we actually connect it via a modeled participation. And that's specific to the scene, similarly with objects for their involvements. But we have, the way that agents connect to the event is through a specific participation that's current to that scene. And so what you end up with in the end is an agent profile that has their sort of fixed part, which is their sort of permanent record, but also what's happening to them over time. And that's an attempt to try and solve this challenge that you have in drama, that you've got this kind of time series ontology to model, but things change over the course of as the story develops. Let's see some of this then in action. Flashing images follow. So we're going to start with a screenplay. In our case, typically that's a transcript that we've pulled off the web. And we want to put some structure around it so that we can address scenes individually. So the first part is a little kind of helper script that pulls down that plain text transcript and converts it to structured JSON. Here we're using the Star Trek TNG episode Measure of Man, which is about proving whether an AI has sentience, which I thought was kind of appropriate. And there we go. So that's our script just in JSON. No AI in this bit. This is just kind of regular expressions and converting text into format based on the way that it's structured. Now, one limitation here is that we're going off scripts, not visuals, not video, and so there's so much kind of story context and perhaps rich detail that you would get from those other mediums that isn't literally there in the transcript. So we also pass in some story context. We're going to give it a scene, but we're also give it in the back. We're going to kind of slip it the whole story so it kind of knows what's going on when it processes each scene. So here we're actually giving it a copy of the real script, not the sort of the transcript, subtitled transcript, but the real script that's got extra like stage directions and stuff like that in it. That might sound expensive, but prompt caching is your friend. We want to make sure that the model output fits the schema. So we want valid, parsable, structured output that we can further manipulate at runtime. Now, there's many ways to try this. I don't know if any of you have tried getting valid JSON out of an LLM. They say they can do it, JSON mode, and all kinds of asking nicely prompts. Never bloody works. But again, shout out to BAML that just does. It's amazing. So we translate our schema into these class definitions, and the BAML library will make sure that our response from the LLM fits this shape. So here we go. Let's run Fabula. It's going to go through scene by scene, pulling out objects, locations, agent involvements, object involvements, organizations with their member list, and more and more and more. So what it does, it actually has a sort of layered extraction approach. It starts with a scene, it pulls out the primary entities, but then the secondary entities have dependencies, because we need a stable set of primary entities that we've extracted across all the scenes and then sort of normalized into a canonical set. Then we pull out the events that are associated with each scene and we associate them back to the agents and the objects. And then we model out the participations and involvements as a final step. That's bitter experience has gotten to that process. So of course, going scene by scene, we have lots of duplicates that need resolving. We've talked about NER earlier tonight. There's various NLP libraries like Spacey that can sort of help with this to some extent. But a language model can make more intuitive leaps. It knows that Jed Bartlett and young Jed are the same person, even though, you know, a string match would never really find that. Not gonna lie, entity resolution has been the hardest part of this process, and not for any of the kind of normal reasons, just actually making it work in code. But look what we've got. We've got now valid, well-structured JSON that's got all our original dialogue, everything that we wanted to pull out, a full registry of objects, locations, characters, and all the things throughout the story. So we've got a very highly enriched set of story moments. And we pulled all that out for an episode in about 40 minutes of processing time. So yeah, what have we got? We've got every story beat from every character's perspective. We've got all the interactions. We've got their movement from one location to another over the story. We've got their emotions and plans that they change over time. We've got a complete inventory of all the entities. And we can do it for any story as fully modeled content types with unique-ish identifiers and friendly JSON, which is pretty good. So if you had a product like this is Apple's Insight. There's also, you know, Amazon X-Ray. You can imagine that kind of metadata being very useful to synchronize against the live action, or do all kinds of clever stuff with, really. Or, you know, make a Mythology Engine type website. What we're going to do, however, is think about how we extract that. Yeah, this is the point I really wanted to make. I mean, we can effectively re-render our content to fit any schema that we want to. And if we do it right, it can happen with very sort of low chances of low error rates, low hallucination rates. And we can actually sort of extract new value and connect new value from existing content. So knowledge graphs then. Neo4j is my graph database of choice these days. It's a label property graph rather than your sort of triple RDF type graph, but it comes with a free desktop client. And so part of Fabula is taking a little post-processing script that turns that structured JSON into a set of cipher scripts, which we then see, I wanted to make these graphs available to you, you see, and that's quite hard to do because there isn't really a place you can go and look at like a full-on knowledge graph online. But I made it so that you could, if you had Neo4j desktop, you could paste it in like this, and then you get something like that. All of this information, this is just a part of it, is connected and queryable now through our knowledge base. Truly the kind of story web that Paul prophesized. So throughout this, I've done a lot of testing with real stories and with some lovely AI fanfic written by Claude 3.5. Here's a callback to the Myth Engine demo. They said they had, what, 7 scenes they managed to get. So we did this whole serial in 2 hours. Yeah, $1.45 to get that out. Yeah, I was surprised at that, but and it's pretty good, you know. The stuff that you get in there, it's not like it's making this stuff up. It's very closely aligned to the source content. Observation is crucial when you're dealing with LLMs. Looking at the tokens going in and out, trying to manage your token budget, trying to see when you're using dynamic prompts, which we are, to pass in context between various stages of the pipeline. You need to kind of see what's going in and what's going out before you actually get your re-rendered content out. It also helps you, manage costs. And with working with LLMs for all this time, I think managing costs is a hugely important thing to get right during development. Some observations. Looking at how responses vary across models. Again, you'd think that maybe the best model was the best. O3 Mini here, which is perhaps OpenAI's best practical model at the moment, actually came in slightly cheaper than 4.0 Mini, and the results were kind of comparable. Dolphin 3.0 free model here actually totally went off on one, wrote way more content, though not always that good at following the instructions. And that's one of the things that we'll talk about in summary. But it is actually about, balancing sort of quality and cost. Context is more nuanced as it comes out. So I mentioned earlier about how we kind of slip the model the whole story. Now, I've tried all kinds of things for that, everything from complete novelization of the episode to just giving it the same transcript but all at once again. And again, you'd think maybe more is better, but there's definitely a sweet spot. This is the one with the full novelization on the first scene of an episode of Doctor Who called Mission to the Unknown. Not much goes on in that episode, so it's kind of, or in this scene rather, so it's kind of amazing that it's been able to pull out this much. In fact, do we have the scene there? That was it. So the fact that it can pull anything from that is quite amazing. By the last scene, the model seems to have picked up enough context from just the batch processing that even with no extra context at all, it can come up with a fairly accurate summary of the event. As I say, adding more context kind of works, but kind of doesn't. Not nearly as well as I thought it might, which is interesting. So still trying to figure out what the sweet spot of story context is there. So LLMs are creative, sometimes too creative. You get oddities when you're pulling out things like objects. and objects like truth, or jaw clench, or rain, or com button, or my favorite, actually, which is a good one, which is Superhands' Minecoin project from the Peep Show fanfic that I got AI to write. Minecoin being Superhands' failed crypto mindfulness app, which, chef's kiss. But actually, what's interesting there is that some of those kind of expose what the model wants to extract, what it's good at extract, and that can sort of lead you in new directions as well. So after about a year of trying to automate the Mythology Engine and using frontier language models and forever in beta software that hardly ever bloody works, so has that taught me anything? Yes, it has. Valid structures output is hard. I say again, everything you've heard of about getting structured JSON out of LLMs, it just doesn't work. And for the longest time, the project was stalled on that because you just couldn't get it out. But finding the right ways to get your output out, just use BAM. It's really good. Creativity versus prompt adherence. This is a tough one. You need the LLM to follow your instructions, but you also kind of don't want a very kind of dry, deterministic response. So you've got to kind of balance your temperature with your prompts, with some of the other parameters. And actually even sort of model choice, I think, comes into this. One of the advantages of the Fabular architecture is that each set of extractions can be done by a different model. So you can use the cheap ones for the basic stuff and more expensive stuff for things that need more reasoning. Consistency and resolution. Yeah, every request to a model is effectively stateless. So maintaining consistency across, say, a whole story is really quite difficult. Getting naming conventions on entities is hard. You know, it'll pull stuff out when at the beginning of a story where it doesn't know very much, and will sort of stick to it, later on when it should know more. But I think these things are kind of solvable. They're just kind of issues that need to be dealt with. Context and coherence. Yeah, like we mentioned before, you want the model to have enough context to be able to sort of make a sensible response. But not so much that it starts to kind of flood its memory and then it forgets what it's doing. Similarly, precision versus recall, how much you extract in a single response, particularly when you're extracting kind of entities or whatever. If you extract a whole bunch at once, they're probably more likely to be internally consistent with each other, but it might pick up fewer of them, if you know what I mean. So again, there's a bit of a dance there. And then scaling uniqueness. My so-called UUIDs are not unique at all, but it was important to make them human readable so that an LLM could write them. And beyond that, I think there needs to be sort of more robust UUID stuff in place. So that's something to bear in mind. If you're starting from the bottom up, how do you kind of plan for what would be completely unique IDs? So my advice, break it all down, decompose your tasks, figure out what it is you're trying to achieve with AI. Separate that into specific tasks, which are going to be done in code, which need to be an LLM. Of those that do need to be an LLM, which need expensive, models with high context windows and great reasoning capabilities, and what can you just do with a llama on your desktop? Because you can mix and match this stuff. Get to know its quirks. As I say, I mean, it's working with these models a lot. They are often quite different in what they do. Right now, Flash 2 thinking is surprisingly good at creative writing, but almost as good as 4.0, GPT 4.0, but Flash 2 thinking is virtually free. Observe every step of the pipeline. Yeah, when you're seeing things going in and out of the model, you kind of watch what's happening. That's the best way to debug, because LLM code, it won't go wrong like you think it's going to go wrong. The program won't just crash. What will happen is it will start generating stuff that just isn't true, or is just kind of so far off. It's very, very strange at times. So you really need to kind of be clear on what's going into the model, what variables it's receiving, what outputs it's putting out before it gets post-processed. Have great test content. Yeah, you're going to see a lot of it. My God, those 4 stories that I was testing with, I must have generated dozens and dozens of versions of the graphs of those, and so I've gotten to know those stories very well. Again, get AI to write your test content because it will write it such that it's very entity rich and it's very kind of suitable for the process. And you do it again and again and again and again and again, and you just flush it through until you get it right. And you get used to the fact that there is these trade-offs and there is this unpredictability, and ultimately it isn't a deterministic system. So what's next? We've got 1 minute. Yeah, we've talked about some of this stuff. LLMs, sub-symbolic architecture, as known, doesn't really have, subjects, objects, and predicates in there. It's kind of a bit more wibbly-wobbly, timey-wimey. But you hook it up to a knowledge base, and suddenly you've got this kind of GraphRAG approach where you can convert natural language questions into graph queries, which in our case means that we can express narrative questions as database queries. So text decipher, yeah. Oh, there we go. Yeah, so this is my very, very rough GraphRAG app. Not brilliant, but what it does, you ask it a question and then it sort of decomposes that into sub-questions. Because most questions people ask, they're terrible questions, they're poorly phrased, they're wrong-headed, and what you need to do is not try and answer that straight away, but break it down into a bunch of questions that might be the thing they're asking and are more suited to the schema that you've got. And then you go and get it to write a bunch of those queries, try all of them, see what's going to work, come back to you sort of and take the results, rewrite them into a nice answer. It's great in theory. In practice, it's very slow, and people have got an expectation set by ChatGPT. But it is the future. So what's next? Timeline and multiverse. So we do have separate events and scenes, but at the moment we don't have a way of reordering them, changing the chronology between them, mostly because that just isn't there in the script half the time. So figuring out ways to kind of do that, automate that is tough. We need extra layers of data. Why not? We can run the same process on the source data again, but this time our schema is all about behind the scenes info, or it's about trivia or retcons or something. We need more ways to consume it. As we've talked about, yeah, what do you do with this stuff once you've got it? How do you make it into a product? We need better ways to fetch context. We need more ways to ingest this stuff. And ultimately, I would love to hear what you guys would do with this. On GitHub, you will find all the code for Fabula, along with some pre-graphed output for Doctor Who, Star Trek, Peep Show, and The West Wing. I would love it if you tried it out, left feedback, or even would like to contribute. I've been Mike Atherton, and thank you for your time. Yeah. Do you see a future where we can do this during the production of stories with writers rather than after? Yeah, kinda. In that it is an ongoing process. As I say, it doesn't. I mean, if I had any sort of criticism of the Mythology Engine idea, it was very much somebody coming in after the fact and doing a sort of post hoc analysis on the story. And that's, that's how people review things. But if you've got a story that is unfinished, that is unfolding in real time, a scene at a time or a moment or a time, then yeah, I mean, you could be doing this sort of on an ongoing basis, essentially, which is almost an answer to that question. Did you observe any model collapse, or would you like to, from feeding LLM outputs to the LLM? David Lynch would have nothing on that stuff. Indeed. Yeah, sometimes. As I say, when it goes wrong in funny ways. I had a thing this morning where I was trying to do map reduction on a screenplay, trying to mess with this, how you get enough context in. It totally gave me a summary of a story it had written itself. Quite happily, the code worked. It was all in the right like JSON format and everything, but it wasn't the story that I'd put into it. It was like something else entirely, which is kind of weird, isn't it? But yeah, things like that are going to happen, and you got to kind of mitigate against them. There's ways to do it. How do you determine what success looks like? Yeah, this has always been my problem, really. I just do it for the hell of it, you know. If I've done it, that's success to me. I don't know. I feel like there's lots of ways that where this could go. I think you can use graph science to, you can do things like community detection to determine storylines. You can do link prediction to kind of anticipate where stories are going to go. You could even, find ways to kind of construct new narrative pathways within an existing story. So you could rewrite the story from someone else's perspective, for example, and it still be true because it's still based on all the source information. How do you pinpoint fine balance when a different LLM goes quirky? I'm not sure what that means, but yeah, as I say, like, well, I mean, the LLM has gone quirky and has pulled out lots of metaphysical concepts as objects, and that's super interesting to me. And what it tells me is that my 4 primary entities aren't enough, and we perhaps need some more granularity there to be able to capture some of these things that the model really seems to want to capture. Thank you.